whenever you're doing a log question and you don't see a base, the base is 10. So we put a 10 there. Now we're going to solve this like we solve normal equation. So in solving normal equation, you would get rid of anything that is added or subtracted first. So we add a 10 to both sides. Alright, that part would cancel. Now we have negative 3 log x base 10 equals negative 6. And then again, when you're solving a regular equation, you'd go ahead and divide by whatever is multiplying your variable. So in this case, we're dividing both sides by negative 3. So this is log x base 10 equals 2. Now this takes us to what we call the exponent law of logarithm. So if I have log a base b equals c, this part is your argument. This is your argument. This is your exponent. And this part here is your base. Okay? So the law says this base will be raised to this exponent, and it will equal to your argument here. So it is just a equals b to the c. This is your exponent law of logarithm. Okay? So that's the law we're going to apply here. So this base is going to raise to that exponent. So it is x equals 10 square. And 10 square, of course, is 100. That is your solution there. Okay? Also remember that you cannot take the log of a negative number. So if your answer is a negative value, then it is no solution. Okay? Example 2. Log 3x plus 4 base 7 equals log 2x plus 11 base 7. Once the bases are the same, you're going to equate the argument. So this is the argument for that side, that's the argument for that side. So we're just equating the argument since the bases are the same here. Okay? So that would be 3x plus 4 equals 2x plus 11. Now of course we subtract 2x from both sides, solving normal equation. So this is x plus 4 equals 11, and we subtract 4 from both sides. So x equals 7. Okay? Now let's see if we can look at another example real quick. Alright. So example 3, we have 7 log 3x plus 1 minus 8 equals 6. Again, if you look at this, you don't see a base on the log. So because there's no base on the log, we know that's a base 10. Okay? Now, again, in solving this normally, we would go ahead and add 8 to both sides. Okay? So this would be 7 log 3x plus 1 base 10 equals 14. And then we divide both sides by 7. So log 3x plus 1 equals 2. Alright? And again, we're applying our exponent law. So this base will be raised to this exponent here. So that would be 3x plus 1 equals 10 square. And 10 square, that is 100. So that's 3x plus 1 equals 100. Okay? Then we subtract 1 from both sides. So let's take it up here. So that would be 3x equals 99. And we divide by 3. So x equals 33. Okay? Alright. Let's go through more quickly. And let's look at another example. Example 3. Here we have log 5 base 2 plus log x minus 3 base 2 equals 4. Now once the bases are the same and you're adding the logs, then that's what we call the product law of logarithm. Okay, so remember, this is the argument and this is the argument, so you'll be multiplying the arguments, taking one log of both and multiplying the argument and keep the same base. So this would be log of 5 x minus 3 base 2, because the bases are the same there, and that will equal to 4. So let's expand the parentheses. So that is log 5 times x, that's 5x minus 5 times 3, that is 15, base 2 equals 4. And again, we're going to apply the exponent law. So once it's something with a base equal to a number or constant by itself, then this base will be the base on this side, and this number on this side will be the exponent for this base. Okay, so that will just be 5x minus 15 equals 2 to the 4. Okay, so 5x minus 15 equals 2 to the 4, that is 16, and then we add 15 to both sides. So 5x equals 31. We divide both sides by 5. So x equals 31 over 5. Okay, or if you want, you could turn that into a decimal, which is 6.2. Alright, but it's okay to keep it like this. Alright, let's look at another example real quick. Alright, so our other example is log of negative 5x base 9 minus log of x minus 4 base 9 equals log 8 base 9. Now, once the bases are the same and you are subtracting, we call that our quotient law of logarithm. So we will use the argument of the negative log to divide the argument of the positive log. Okay, so we're taking one log of both, so that's log of negative 5x, because that's the argument there, divided by this argument, which is x minus 4, and then we keep the one base here, which is 9, and that equals log of 8 base 9. Okay, now once the bases are the same as we discussed before, we're going to drop the log and just equate the argument. So this is the argument for this part, and this is the argument for this part. So it would be negative 5x over x minus 4 equals 8. Okay, and then we can go ahead and multiply both sides by x minus 4, which is the content in the denominator. So that's x minus 4, and I'm multiplying this thing by x minus 4, just the same. Okay, so this x minus 4 will take out that x minus 4. So what I have is negative 5x equals 8 times x, so we're distributing. That is 8x, 8 times negative 4, that is negative 32. Then we subtract 8x from both sides. Okay, so this would be negative 13x equals negative 32. And then we divide both sides by negative 13. So x equals negative divided by negative is positive, so that is 32 over 13. Okay, and it's safe to leave it like that, or if you want, you could convert that into a decimal as well. Okay, alright, let's go through. Let's see if we go through a few more examples. Alright, now we have ln 2x minus 4 plus ln 5 equals 3. Now, ln, once you don't see a base on it, the base is, or the base for all ln is e. Okay, that's your natural log. Okay, so that's e there, and that's e here. And we're going to apply the same law, that the law of logarithm. So once you're adding, you're going to take the product of the argument. So you're going to use this to multiply this thing here. Okay, so let's do that. So it is ln of 5 2x minus 4, keep the base, which is base e, and that equals to 3. So this is ln 5 times 2x, that is 10x, minus 5 times 4, that is 20, base e equals 3. Okay, again we're going to apply our exponent law, so it will be e raised to the 3 there. Okay, so this is 10x minus 20 equals e to the 3, and the exact value is to keep it in terms of e, so we could go ahead and add 20 to both sides. So this is 10x equals e to the 3 plus 20, and we divide both sides by 10. So x equals e to the 3 plus 20 over 10. This is your exact answer. Or you could have the approximated value for this. Let's take it from right here. So if we have 10x minus 20 equals e to the 3. E to the 3 is an actual number. So let's see what that is on our calculator. Okay. So to get the e, it's second, and we hit the ln button, and that's e, and we put the 3 there. So e to the 3 is approximately 20.09. So this would be 10x minus 20, approximately 20.09. And of course we would add 20 to both sides just the same. So 10x would be approximately 40.09. And again we would divide both sides by 10. So x would be approximately, so if we add 20 to that, that's 40.09, and we divide that by 10. So x would be approximately 4.01. Okay. All right. So let's move into our final example for this video, and it is ln of x plus 5 minus ln 7 equals 4. Again, remember that the base for ln is e. Okay. Now remember that once the bases are the same and you're subtracting, then that's a quotient law. So you're going to use the argument of the negative ln or the negative log to divide the argument of the positive ln or the positive log. Okay, this would be ln x plus 5 divided by 7 base e equals 4. Okay, and again you're applying your exponent law, so it would be this argument equals e raised to that exponent there. Okay, so this would just be x plus 5 over 7 equals e to the 4. Let's work it in terms of e first. So we would multiply both sides by 7. So this would be x plus 5 equals 7 e to the 4. And we subtract 5 from both sides. So x would equal to 7 e to the 4 minus 5. This is the exact answer. Okay. Or let's put it in terms of a decimal. We can pick it from right here. So it would be x plus 5 over 7 equals e to the 4. But again, remember e to the 4 is a number. So let's find what the value of e to the 4 is. So we hit second and the ln, that is e, and we got it to the 4, which is, that would be x plus 5 over 7 equal approximately 54.6. Okay, and we will multiply both sides by 7, and that would cancel. So this would be x plus 5 is approximately, let's times that by 7, so approximately 382.2. and if we subtract 5 from both sides, so x would be approximately minus 5, 377.2, and that would be it. And that's it for this video. Thanks for watching. Hope you have learned something.